All right, so let's get started. I'm gonna try to finish on time so that we can head out today. Before we all go away, we would love to take a photograph of the whole group. So about right after this lecture, we'll head over to the steps of the economics department, and we'll try to take a group photograph with everybody to commemorate this wonderful group. Okay. All right. So I'll try to finish on time so that we can head that way. So I'm going to be talking about how to analyze the types of models that you've looked at with Irene and with Paulo. If you have data only on the final matches, and as compared to what Paulo talked to you about, we're going to think of a situation in which the econometrician does not know the preferences of both sides of the market. So if you think about Irene's example of PhD admissions, what she said was, what you guys learned was that, okay, in your discussions that the students are applying to various PhD programs, the PhD programs are ranking schools, and let's say I see where every student goes, okay, but I don't know either the rankings of the programs for the students or the students' preferences for the programs, and I want to learn both. Okay, so this is kind of a common situation that you might have in the real world, and let's think about how we can go ahead and make progress there. And so again, we're going to try to go back to these kinds of choice models that Paulo laid out, that Irene laid out, and we start these models in this literature using the preferences of agents, because they really are the primitives that are determining things like efficiency and sort of the equilibrium conditions that we're going to work with. Okay, and I want to take a step back and say that there are two real reasons why we try to do this. The first reason is we're interested in some kind of policy analysis, a positive analysis of what the world would look like if you changed something about the world. For example, you might be interested in learning about what students value, whether they value good schools or not, which is going to be an example that we're going to see later, we're going to see tomorrow. And what would be the effects of various types of interventions, not only from a welfare perspective, but maybe who would go where, how much tax revenue would you get, how much would you spend extra, etc. So just to describe what the matches would look like if you, for example, had a quota, what would be the distribution of students in various places, etc. And these models are going to give you a way of analyzing these questions by taking into account the general equilibrium effects that come in, as opposed to thinking about sort of partial equilibrium changes. So that's really what the power of these models are, right? And then you're interested in the normative analysis as well. You want to compare mechanisms. You want to see the distributional effects of various kinds of interventions. So that's another role for this kind of work. And as Irene mentioned, there are some cases in which the theory does not give you very tractable answers. That's one role for empirical analysis. And the other role of the empirical analysis is to give you a quantitative understanding of what kinds of trade-offs matter. So Paulo showed you that graph from my paper on New York City that showed you what features of the mechanism quantitatively matter more than others, right? So theory can give you binary answers. Can you satisfy strategy proofness, spirit of efficiency, and stability at the same time? You'd get an answer that says yes or no, right? But you would not necessarily know what is the value of these various types of features, or what are the costs of these features on the welfare perspective. So that's sort of another role of empirical work. And here we again are thinking about a review preference approach. When you did consumer choice, you said that your consumer can go to the grocery store and pick whichever box of cereal they want at the posted prices. Kellogg's Cornflakes does not care who you are when you pick up that box. All they care about is whether you're willing to pay that $4.50 if you're in Cambridge, or less if you're in a place that's not as expensive. And that's how you sort of basically do review preference analysis in the consumer choice setting. In matching markets, that does not necessarily work. Okay, you can't just choose what you want. You must be chosen from the other side. You can't just decide to enroll in the PhD program that you want. They have to give you an offer. In most countries, your partner has to agree to marry you. You can't just show up to work in Google. And that kind of happens everywhere, right? So on a peer-to-peer platform like Airbnb, the host has to say, yeah, I think that you'll be an okay guest. Maybe not so much, but maybe that sometimes happens. So matches form by mutual consent, right? And so just by looking at where everybody is, you can't necessarily know that that was their favorite box of cereal, that that was their favorite program. So I'm at MIT, maybe MIT wasn't my favorite place to be, okay? And so on. So you have to start thinking about that. And you've already seen a flavor of this. So when I look at the data set in a particular market, right? I don't just look at the data set and think about that data set and what it tells me in absence of the market institutions. I need to understand what those fields mean and how they were generated. How did that match come about, right? How was that rank order list generated? What was the incentive of the agent, right? And so Paulo thought about that very carefully. He thought about how exactly a person should think about ranking schools. What would be the advice you would give? You would say, okay, think about your chances of getting to various schools. And that depends on the institutions, right? So so a market designer really understands these roles. And once they understand these rules and exactly tries to think about how these agents are participating in this mechanism, tries to come up with a way of how to interpret the data. Okay, so you have to think about this, think about the rules particularly, right? So when you see somebody matched to each other, they don't necessarily, they're not their sort of soulmates necessarily. Maybe they had somebody else they liked, but they weren't willing to match with them, right? So same thing with college admissions, etc. And we saw that agents need not submit preferences truthfully. And so we want to do this kind of analysis. And as Paulo mentioned as well, one thing that is great about centralized marketplaces is that you get organized data from the administrator that is usually running this system, right? So that has a few different advantages. One advantage of that is that you have great data on exactly what happened in the market, okay? Because the person who's running the market had to keep records usually, right? And those records become a source of data, right? And so as a market designer, what you want to do is you want to make connections with these people and try to figure out whether you can get some data, right? So I want you guys to be, and my PhD students here have heard me say this before, the goal is not to have you be only consumers of economics, it's to make you producers of economics, right? And so if you want to be a producer of economics, you want to think about how these papers are written, right? So one way that happens is to try and go into the real world, engage with people who are running these marketplaces, try to get their data, try to understand the types of issues that they're facing, and try to talk to market participants, think about how they are playing this game, maybe what they understand, what they don't understand, and then use that to try and devise your empirical strategy. Sometimes a great source of questions, right? So the issues that a market designer is facing in the real world, the practitioner is facing in the real world, becomes a good motivation for an economic question. We'll see an example of that later in my lecture as well. Okay, so understanding all of these things, and markets come in all shapes and forms and sizes. All of these things can help you really in many ways in formulating a research question, in formulating and making it happen. Okay, so it's not just about economic theory and econometric theory. You have to engage with the world in order to think about how to devise empirical strategy. Okay, so okay, so that said, I'm going to set some of these things aside, and I'll touch back on those themes when I talk about my paper. One of the things that's good about talking about your own paper is that you know how the research was done, right? Because you did it, right? And usually, when I was a grad student, I would sit down in my classes and just see these papers written, and I would be like, okay, how do I ever produce this, right? It's like it seems like an impossible task, right? Still today, it feels like an impossible task in many cases, right? And so maybe I'll tell you the story of a paper or two, and you'll see how you can translate sort of some of your work and the techniques that you're learning and how to sort of produce that paper. Okay. All right. So using final match data. So school choice models use these data on on the rank order list that people reported. That was a very common thing. And then you use this data to understand the mechanism, and you backed out under some assumption on behavior, whether it's equilibrium, whether it's truthful, whether it is some more naive approaches which have been followed up. You can try to work out what their true preferences must have been. Okay. Now let's say you've only data on the final matches. You only say who got matched to whom. You don't have access to this data, but you want to learn exactly what Paulo taught you how to learn, the preferences on both sides. So let's try to do that. And there are lots of good reasons why that might happen. One is that rank order data is not even collected. So employer and employee match data is common. In the PhD admission cases, I don't know of any central body that collects all of the admission data, right? So we don't necessarily know who applied where, and we don't know what the programs ranked, etc. But you might know who enrolled where. In colleges, for example, it's not that difficult. There are people who worked out where people have enrolled. So there are databases of these. For confidentiality concerns, sometimes the market designer is not willing to give you that data. So this is a constraint I faced when I was trying to write my thesis on the medical match. I asked the NRMP, which was the market designer, can you give me this data? They said no. And I said, okay, why not? And they said it's confidential. Al Roth was one of my advisors who helped design the system, and he couldn't help me either, right? So it was kind of difficult. Marriage markets, you don't have data, etc. So now I want to learn who likes what based on the final match data. And this is a tough problem. This is a tough problem, and maybe a non-starter, because there are two sets of preferences that are determining these allocations. But we made some progress on this question, and I'll tell you exactly how. I'll start off with the non-transferable utility framework. Try to give you the sort of broad strokes techniques here, and then discuss an application based on my own work. Okay, so let's start off with this non-transferable utility model, and I'll describe an aspirational framework. We haven't gotten there yet. Okay, we've made some progress towards figuring out how to make this aspirational framework work, and I'll tell you how far we've gotten. Okay, so after that, I'll talk about particular simplifications that we worked out. Okay, so this aspirational framework borrows from a survey that Paulo and I wrote. All right, so you have a two-sided matching market. You have agents indexed by I on one side, and you have agents indexed by J on the other side. Okay, so workers and firms. All right, workers are indexed by I, firms are indexed by J, and agent I, so a worker can match with at most one firm. Okay, you can't have multiple jobs. And a firm can hire many workers, up to QJ workers. Okay. And preferences in the aspirational framework, in the most general form, will be a random utility model that is quite flexible. We're going to have the utility of I, worker I, from matching with firm J, depends on some characteristics of the firm that are observed in the data set that are going to be captured by XJ. Zi are going to be the characteristics of the worker that you observe. XCJ, unobserved characteristics of the firm. Epsilon I is a vector of unobservables that are worker specific that has unobserved heterogeneity and preferences. It could be J, it could have very large dimension, it could have random coefficient, it could have idiosyncratic shocks, etc. Okay. The Greek stuff is not known. The Roman stuff is known. Okay, the U's are not, but the bolded Roman random variables are known. Okay, and there's some Dij, which is a worker firm specific characteristic. Okay, so similarly, there's a utility of J for matching with I that looks like the following. There's an XJ like before, there's a ZJ before, there's an eta I. It's not going to be easy to have worker specific fixed effects because of the incidental parameters problem. There'll be, just one worker will be observed once, so we don't have unobservables like XCJ that are fixed effects. And then there's WJI, maybe something that is worker firm specific. One thing that's interesting about the way I wrote this, that D and W only influence one side of the market, but not the other. Okay, and there's going to be an excludant restriction. So you might need to have, even in this aspirational framework, there's some embedded restrictions that the characteristics that only affect the workers' preferences of the firms and vice versa. Okay, and then we'll typically make the independent assumption that conditional on the X's and the Z's and maybe the firm fixed effects, the vector of unobservables of the worker and the firms are independent of the excluded characteristics D and W. Okay, so that's what preferences look like. We're going to assume pairwise stable matching. Okay, so somehow your market arrives at that pairwise stable matching. All right, that's an assumption on what that equilibrium is described by. In some cases, you can justify that assumption based on institutional detail, like there is a centralized match that uses a stable matching algorithm. Sometimes you can't, and you might question this assumption. You will see that a lot of these papers are going to use not necessarily exact pairwise stability, that Alice was matched with MIT and Bob was matched with Harvard, and the identities of Alex and Bob matter, but more about sort of the characteristics of the type of people who go to the various types of jobs. Okay, so we will use pairwise stability in the formal sense, but we will use somewhat less restrictive implications of pairwise stability in the empirical strategy. Okay. Any questions? Yes.
Is there a very Hale type result for these sorts of models?
Excellent question. So Berry and Hale are perhaps the canonical non-parametric identification result for demand models for consumer choice. And the answer, the short answer is stay tuned for I think either Friday or Saturday, I don't remember when, but Paulo will be talking about, if he's here, unless he has to rush back to California for personal reasons because he's expecting a baby soon. Sorry to reveal that, you know, he might tell you the closest that we've gotten to that. But the short answer is, even in that case, we have to make some further restrictions because we don't observe as much as you know, we have some more confounding things, and I'll give you a sense of what that confounding variation is. Okay. All right. Now, you know, one thing that happens when you're a consumer of economics, particularly a passive consumer of economics, you can look at a model and you can be like, oh, this looks pretty cool, pretty general. I'm used to writing this, right? But I think you should pause every single time and say, what are some implicit assumptions in these models that aren't written down, right? That you went too quickly, okay? And I'll list 4, all right? So the first one is there are no externalities. So I don't care about who you match with, okay? Now, if you think about your PhD admissions, you do care about who else is in your cohort, right? So there are potentially peer effects. In models of industrial organization, if you're thinking about matches between firms, then you know you care about it because who your competitors are matched with will affect your downstream competition, right? And so you know, you see this assumption and you're like, okay, can I do something about this? That's a paper. That's how you become a producer. Okay, and so there's some extensions of pairwise stability that have worked for this case where there's some kinds of externalities cited them here, but it's just one issue is that notions of stability when you think about relaxing the no externalities assumption is kind of hard. Okay, and so there's some progress here. Then you can read these papers if you like. Second, there's no frictions in matching. Pairwise stability is a you know, strong assumption. It's acting as if any potential blocking pairs have been realized. It assumes full information. I know exactly what everybody else's preferences are implicitly. Otherwise, you would question why you got there. Okay, and there are well-formed preferences. Narita talks about a case where people don't necessarily have well-formed preferences and they learn during the market. Exogeneity of unobservables. So you know, there's you know, the Berry and Hale papers sort of think very carefully about prices being correlated with unobserved demand, and so that sort of is one issue that people sort of people have to deal with. Transfers, if any, are fixed and they're not negotiated. So you cannot negotiate for a better stipend with your PhD program if you wanted to, right? So those are some assumptions. There's some work on fully transferable utility that is cited here. I may not be able to get to thinking about what those models imply. Okay. Any other implicit assumptions that maybe I didn't even notice? Probably there are some. Okay. So so let's think about a simplification of this aspirational model, extremely aspirational, extremely general model called the double vertical model with very restricted heterogeneity. And then we'll think about how we can identify something there that'll give you some limits and give you a sense of the challenge here. Okay, so the key question, which I want to restate, is that it is hard to learn about the preferences of both sides of the market using only final match data. This wasn't the case in consumer choice. If I saw you buy that box of cereal, I know that you liked it the most, or I'm willing to assume that you liked it the most amongst the boxes of cereal that were available, right? If I see you at your university, I cannot conclude that, okay, unless I see where you got admitted, right? So let's think about the model in which the utility of every worker for firm J is the same, uj. It's given by u of xj plus xej. And the value of every worker to every firm is vi, v of zi plus eta I. Okay, no heterogeneity whatsoever, observed or unobserved. Okay, very simple stylized model. All right, so this was the first model people worked with. Okay, because it was a tough question. I worked on it as myself as well, and I'll tell you a little bit about that process. In this model, there is perfect assortative matching on U and H. Okay, so the highest quality worker goes to the highest quality firm, right? So there's quantile matching. The median worker is in the median quality firm, etc. Let's say for now, to start off, every firm can only hire one worker. Okay, so you get to the top worker goes to the top firm, etc., and you get down the whole thing. Okay, and so in this simple model, I will tell you what we can learn if you just observe the characteristics of the workers and the characteristics of the firms they match with, right? And then I'll tell you why it's important and necessary to use many-to-one matching structure. Okay, and then I'll discuss some heterogeneity in preferences, and Paul will teach you more about that in the conference. Okay, so imagine that you had data on the sorting patterns that are summarized by the proportion of people of each type that are matched to firms of each type. Okay, so let's think about medical residency, where there's a resident who has a characteristic, observable characteristic, high or low, maybe high test score and low test score, or high quality medical school and low quality medical school. And the program characteristic, is it in a large hospital or is it in a small hospital? Okay, and what you see is that 30% of the matches are between high scoring medical students and large programs, and 20% are between high scoring medical students and small programs, and so on. Okay, so let's take a look at this. Well, right off the bat, you don't know whether high is better than low, even though I kind of hinted at it, or that large is better than small, because it could be that low is better than high, right? So you need a sign restriction one characteristic, right? You need to know that high test score students on the distribution of quality of high test score students is higher than the distribution of quality of low test score students. If you're willing to make that restriction, okay, which is not that problematic in my view, once you talk to enough people in the institute who play with who are actual market participants, you might use that as a source of making assumptions, right? Then you might conclude that large hospitals are better than small hospitals. Okay, good, but there's a limitation. Okay, you can't learn about preferences on both sides of the market from this. Okay, so it could be that every student who has a high test score is better than every student who has a low test score, and only 60% of the hospitals large hospitals are better than the small hospitals. Or it could be that every large hospital is better than every small hospital, and only 60% of the high scoring medical students are better than the other ones. Why? Because if 60% there's a 0.6 probability that a high resident goes before a low resident. They pick a large hospital whenever they get the chance, and you get this 60-40 ratio in the columns. And then the low guys go, and then they pick whatever they can. So you cannot distinguish one from the other. All right. I wanted to estimate preferences on both sides of the market, and I was stuck at this point for a long time. And I'll tell you a little bit about how I worked it. Actually, I'll tell you a story. Okay, so I went to a PhD program down the street where most of my peers most of my colleagues, most of my classmates were coming from fancy universities. I went to Brandeis University, which is the 42nd ranked university in the United States. Okay, and I was at a party, and somebody asked me, they didn't mean to offend me, Like, okay, you went to Brandeis, so how did you get to Harvard? And I didn't really, and I was like thinking about this problem at that point. And afterwards, one of my close friends was like, there must be something else about you. So we'll see what that how that insight helps later on. But anyhow, so you have this problem, right? You need to figure out what is important, right? So let's go back to the model. You've got this U and V. The U depends on X and V depends on Z, and there's a parameter alpha and beta. So to think about this like resident program characteristic matching, formally what you've got is that a high value of beta, a high magnitude of beta, and a low magnitude of alpha is indistinguishable from the reverse. So the magnitude of alpha is high and the magnitude of beta is low. Okay. The non-parametric version of this is there's a distribution of utility FU, and then you take the quantile match. This term in the middle tells you the quantile match. That the quantile of maybe I got this wrong. So there shouldn't be an inverse here. Sorry, this should be an FV, not an inverse. So FV of VZ plus eta is the quantile of the ith resident. And I take the inverse quantile transformation, and that tells me the quantile of the utility, right? And if you examine this equation, it should look like a nonlinear equation with two errors, right? And you can say that this is not identified if I don't know FV and FU. Okay, so that tells you that the model with just the information on sorting patterns is not identified. Okay, even if I knew V, even if I knew the function V and I knew the function U, it wouldn't be identified. Okay, so why are matches from multiple? Why is many-to-one matching useful? So the question is, are residents matched to the same program? Do they have similar characteristics, observable characteristics? Okay. So if there are two residents that are matched to the same program, they must be somewhat similar quality, right? So that explains the interaction that I just told you about at that party, right? My observed characteristic was low, and my friend was saying, to try to make me feel better, that something else must be there, right? And so the fact that there's heterogeneity in these observables within a program tells you that the unobservables matter, right? It's not that Harvard only wanted to admit people from the elite institutions because that wasn't a perfect indicator or perfect proxy for potentially the viability of a student. So if it is the case that programs have very similar values of resident characteristics, it must be that explains a lot of the variation in quality in this simple double vertical model, right? But if it's not, then the answer is that there must be something else. So let's think about just the case where there are two residents per program, okay? And I've got the equations again. Now there are two different residents, I and I prime, that are matched to the same program J, okay? And pardon my typo, there shouldn't be an inverse on the F. Okay, now we again have quantile matching. So these two residents must be of basically in the same quantile in a large enough market, right? And so what you've got is that FV of the total quality of resident I is the same as the FV of the total quality of resident I prime. Okay, and once I subtract XCJ, I've got the same U on the left-hand side. Okay, so I can think of the observed characteristics of each resident at the program as a noisy measure of the quantile of the program that they're matched with. Okay, does that make sense? Yes.
Does it say anything about that the distribution must be in some sense homogeneous? Like you might say you might take two different distribution and match to a certain program. Let's say we need an equal amount of men and women, and then we're like.
Yeah, in this model, I'm trying to use this model, the simple double vertical model, not because I think it's realistic, but as a way to understand how this what the empirical challenge is and how this model works, how the stability works, right? So yes, it's making a very strong assumption that preferences are homogeneous on both sides, just to understand what's going on. Okay, I'm not trying to say that the world is described this way.
No, it's just also just to be.
Yeah, but yeah, it's very. There aren't any distributional constraints. As they're not thinking about diversity, etc. Okay. So you've got two noisy measures of the same observable characteristic, and that tells you once you think about this, right, and inspired by this conversation at this party, you think about measurement error models, non-linear measurement error models like Hu and Shanek, and you can make some progress. And that's sort of what my friend and I wrote in a paper to try and show you how to identify this model. Okay. So let me tell you a little bit more about the research process. So it wasn't just the party, okay, because that would tell me that you should go to parties all the time. No, but they're useful. There's another sort of research process point that I want to make. So when I was trying to work with this model, I was trying to do what the previous researchers did, looked at the sorting patterns and tried to construct objective functions using that sorting pattern. And I was like, okay, is this thing going to work? Now remember, Whitney told you that in order for your likelihood or GMM or whatever to work well, there needs to be a unique point in your of your objective function that unique value of the parameters that minimizes or maximizes the objective function depending on whether your objective function calls for minimization or maximization. So one thing you can do is you can take a very stylized simple model and you can simulate your objective function of interest and see what that objective function behaves like. Okay. And so here's an objective function based on this simple linear model where X and Z are normally distributed, Xc and epsilon normally distributed. And I simulated matches from this model, computed the sorting patterns, and try to match moments. The true parameters out there, and you see this these contour lines of the objective function. The valley is where you see a bunch of minima, right? And just using sorting patterns, you have this the intuition that I gave you, high alpha, small beta thing, right? So it's sort of at this kind of stage when I went to the party. And then after the party, I did something else. I said, okay, let's look at the variance of the characteristics of the residence within my program and construct a new objective function using that, just that, and simulate it again. Okay. And that objective function had a value too, but the lines were different. The lines were vertical as opposed to diagonal. Okay, so one set of moments, and it's actually kind of beautiful if you think about it. This moment itself tells you exactly what alpha is, right? The true value of alpha is in the middle, and all the contour lines are vertical. That means this moment, which is the within program variance, pins down alpha. And you can only construct that if you had data on many-to-one matches. Okay, so now once I've got alpha, if I go back to this other objective function, I can read off beta. Okay, and you put them together and you get this beautiful shape that you love, right? And so that sort of this kind of Monte Carlo simulation helped us figure out the non-parametric proof as well. Okay, so if you're like trying to work out why something is identified, this might not be a bad tool to sort of build intuition and then try to understand which way to proceed. Okay. So the short of it is that many-to-one matching is important. Okay, in order to try to make progress in the cases where you only observe final match data. Okay. All right. So now let's think about adding some heterogeneity. Okay, and I'll tell you about how people added heterogeneity before. There's a very nice paper by Menzel in 2015 in Econometrica that goes to the type 1 extreme value or beloved sort of distributional assumption and writes down the following model. Uij is u of xj plus z, right? Some observable function of x and z, plus IID epsilon I ji shocks. V is similar, some other function, plus IID extreme value shocks. Okay. The beauty of logit and how it works out magically gives you this answer that says that the density, or the, so if you think about this as discrete, then you can think about the probability mass. If x and z are discrete, the probability mass on matches of types x and z divided by the probability mass of z and the probability mass of x has this formula which says it's equal to the x of the sum of the u and the b. Okay. If you think about this, the IA property is really playing out, right? So I mean, once you work through this math, and it's it's a bunch of complicated math, but it's IA all over, the log sum formula all over. Okay. The beauty of this is very trackable. It actually generalizes to beyond logit, as long as the tail behavior of your epsilon ij shocks are in the domain of attraction of the Gumbel distributions, okay, which is a pretty large family of distributions, and only the tail behavior matters because if there are lots of people in the market, it's the highest order statistics that matter. Okay, then it sort of looks like this in the limit. But again, if you think about this, this is for one-to-one matching. You only have the sum of the utilities that are matched or that are identified. Okay, you don't have the individual components. You have U plus V, but not the individual components. And Menzel's working with the model with one-to-one matching. And so even with the heterogeneous case here, you have a situation in which you've got only something more limited than what you might hope for in your aspirational model that is identified. Okay, agree with me? All right, great. So Paulo didn't mention this, but the sort of the short of it is that in these models, the non-parametric identification results are much more limited than the case with the school choice case. In the school choice case, in the models that he showed, in all of those models, you actually have non-parametric identification, the distribution of indirect utilities. Okay, so the distance variable moves things around enough in those models that you can actually get the distribution of utilities. Okay, and so for the particular parametric form that he wrote down, that is a particular there's a particular subclass of models, and so that also verifies Whitney's required condition that there's a unique optimizer of the objective function. Okay, so we don't have a analogous non-parametric identification result for these models yet. Okay, slightly more limited result we're going to see in the conference. So let me tell you about how this was applied in the medical match data. Okay, so the medical residency market. I'm sure many of you have friends who are going to medical school and maybe now at this point are applying to residency, right? So the medical residency market is something that you must have heard about, and you must know about the stress that goes with it. Okay, so it uses the Roth-Beranson algorithm, which is a variant of the deferred acceptance algorithm to account for the fact that medical students date each other and sometimes they want to look for jobs together. Okay, and so if you were participating separately in the match, then you'd have the joint location problem, and maybe your partner would be matched across the country, and that wouldn't be a very good situation to be in. And so so the Roth-Beranson algorithm allows medical students who are matched to other medical students, who are partnered up with other medical students, to solve that dual career problem in a more seamless manner. Okay, there are about 1,000 of them every year that participate in that way. So again, the NRMP wasn't willing to give me the match data, even though I pulled the poor grad student card. whose advisor was, beating down on him, which is a useful card sometimes. Use it, but know that doesn't always work. So this is how it works. So in the NRMP, it's a centralized assignment process. First, what happens is that the positions are advertised in October. Then the residents apply to these positions. A subset of them are called to interview. And maybe like 10, 11 interviews per resident. And then they submit a rank order list of all of the programs that they interviewed at. And then this algorithm takes over. It produces a final assignment, which is announced very publicly on the third Thursday of March. So that's how that works. Okay. So let's pause here for a second and think about what are some of the differences between this market design and other market designs. So every market has a design. All right. It's either intelligently designed or not, but it has a design. Okay. So like the PhD admissions process has a design. Okay. And we discussed what that design was. So what are some differences between this process and either the PhD admissions process or other job markets?
What's centralized?
Centralized, right? So can anyone think of any other labor market that is centralized?
Things like Uber, maybe.
It's not a labor. Maybe, yeah. Okay, yes, fine. If you think of the drivers as their labor market, that's okay. Good. Any other labor markets?
Yes, economics, a rookie professor job market.
So maybe depends. Centralization is not a binary thing, right? So depending on the definition of centralization, somewhat centralized. We all go to the AEAs. It's all coordinated in a compressed amount of time. The interview process is somewhat centralized, right? But there's no central clearinghouse that clears it. Anyone from France? France? Teachers. Okay, great. Anyone from Latin America?
Colombia, also teachers.
Colombia teachers.
So the Indian civil service.
Indian civil service. Okay. Other example?
I think the Unification Church did mass marriages, right? They call them the I don't know if that's a serious example or not.
I don't know about that example enough to comment. These are all examples of centralized marketplaces. In fact, I didn't necessarily know about them. People are bringing in these examples and bringing in data from these examples, analyzing unique issues about that. What's the difference between the market for teachers or the market for all the other markets and this one? What's one difference?
It's sort of nested, like you have to choose your specialty.
You have to choose the specialty, but you can apply multiple specialties in this.
So you submit ranks for only the places that you're interviewing. So you get like a signal and then
Yeah, so in civil services, it's sort of it's a slightly different thing. One thing that happens, there's a test score that determines your what your priority is. Okay. What about other labor markets? I guess maybe you guys haven't participated in the labor market, but it's kind of typical to negotiate on your salary, right? So it's like, okay, I've got these offers. Can you match that other one? Right? So any guesses on how much medical residents make as salaries? 4 years after doing MD. So in the United States, for those of you not from here, you do college for 4 years, then you do your MD, and then you go into this market. Any guesses?
80,000.
80,000?
50.
50? Who's with Harry? And who's with, okay, so very few people with Harry. Who's with Catherine? Who's with Catherine? Okay, come on. This is a binary choice. You can't be indifferent. Who's with Catherine? Okay, 10, 11. Who's with Harry? Many more. who thinks it's okay? It's 50. Why did Catherine think it was 80? These guys are doctors. They've like got 8 years of education. They can do something useful, you know, and they get 50,000, right? I bet some of you have stipends that are more than that, right? In grad school. Not to say you're not doing anything useful, but it seems unfair, okay? And so the resident said, you know what? This is like, who thinks it's fair that they make 50? Who thinks it's unfair? Most people think that. More people think it's unfair. I think it's unfair. Anyhow, the residents got together and they're like, you know what? This is kind of crazy. I did undergrad, I did my MD, and you know, I get paid $50,000. The nurse practitioner and the PA gets paid much more. They get paid like 80, right? Why is that? Is it? And so they came up with the question. They said, you know, it's because you don't let us negotiate. Right? So they said that it's the match. We established that this match is somewhat unique, right? We established that hopefully that, you know, they get paid a little, they don't get paid as much as we think they should. And they said, okay, like these two things are sort of, you know, correlation, causality, this is the reason. Okay, so they sued the medical residency program saying that the centralization is the reason why the salaries are 50 instead of 80, okay? What other healthcare workers are getting, okay? So getting to know the market and what are the unique things about that market, how it differs from other markets can help you think about questions. And you know, it's an interesting question. Is it the case that this kind of centralization is going to depress salaries? So that's what we're going to try to. That's what I try to address at any rate. You know, to be completely honest, the third year in me or the fourth year in me was like, okay, let's do the nerdy thing of trying to figure out preferences. Not so much engaged into the question, the economic question. And then as I sort of matured, I was like, okay, this question is important. So let me also go after the question. Okay, so there's an evolution there. Yeah.
Maybe I'm not quite familiar with the like institutional background, but could they adjust their hospitals in the future? You know, your wages like determine when they initially match, that they can like bargain in the later years.
No, so the salaries are set.
Like also for the future.
Yeah, so it's just a function of how many years of experience you've got, but it's set. It's also not uncommon in, you know, if you're a postdoc in the sciences, that's also how it works. Okay. All right. So the two questions that that was addressed in the original version of the paper, one of them is how do government regulations affect, you know, incentives to try to get more people training in rural areas? How would that, incentives versus quotas, how would that affect the final matches? So that's like a positive question. That comes up in, did you say Peru?
Colombia.
Colombia. Okay, so you'll see a paper on Peru, I believe, where this issue shows up, and you know, there's an effect of, you know, maybe putting subsidies, loan forgiveness programs for getting residents to train there, so that there's more medical supply of labor there. So that's sort of one question that was addressed. A second question that was addressed was exactly this idea of why is it the case that Harry is right and Catherine isn't, you know, so this antitrust lawsuit was about what is the role of the match and is it salary depression that is causing it. Spoiler alert, who here took the highest stipend offer to the PhD program that they went to? Okay, this was coincidental, I'm assuming, but you don't necessarily think about the stipend, right? I for one did not take the highest stipend offer, right? Because the PhD program was an investment in my future earnings and the training that is going to give me, right? Similarly, residents care about the training that they're going to get, and they care much more about that than the salary necessarily. And so there's going to be some limitation to how much salary bargaining is going to get salaries up to the levels that Catherine was mentioning. Okay, so the data is going to be on stable matches, final stable matches. So I got this data not from the NRMP. I got this data from the American Medical Association, the poor grad student card did work. They have a census of all residents and of all residency programs and say, okay, who are the residents that are working that are at your program? Tell me about their medical school and their background, etc. So your data set on which residency programs are out there, the residents that work there, but you don't know the whole underlying matching process. Okay, and it's pairwise stability, which you guys know. I'm going to assume it's stable. And the first thing that you might ask is stability a good assumption, and why might it not be a good assumption? Okay, so there are a couple of things here. There's an interview process, and the interview process might result in violations of stability, right? Maybe the right person is not interviewed. Any other reasons why stability might not be exactly right? Yeah, go ahead.
There could be some two-body problems.
There could be some two-body problems, yeah. So maybe the notion of stability that we're going to use is not quite right. Do any of your medical students ask you how to game the match? Your friends, yeah. They think that they can game the match. There's some signaling potentially, right? So there are some reasons why stability may not be exactly right. But I'm going to pretend and that stability is okay. This is Harry said that researchers are good at pretending, but you will see also that it's going to be the characteristics of residency programs and the residents that we're going to use. So it won't matter so much whether Alice or Bob match with MGH, Mass General Hospital, but like the characteristics of the people that matter. Okay, so we have data from 8 years. From the American Medical Association. The multiple years are going to be used primarily for precision. I'm not thinking of this as panel data with large T. It's more like large N data. And I see the residents' birth location, which medical schools they went to, etc. And you have a relatively extensive set of characteristics for hospitals. In 2010 dollars back then, the average salary was $46,000, and there's some limited dispersion around it. Okay. Residence preferences are going to be based on the Berry and Pecos pure characteristics model. So UIJT will be some characteristics, observed characteristics, ZIJT times beta I, plus delta times the salary, the wage, WJT, plus XCJT. Okay. In the paper, we will allow XCJT to be correlated with W. So there'll be an endogeneity problem, and we'll solve that using a control function approach and an instrument. In the interest of time, I'm not going to discuss that. Okay. And so there's some program characteristics that I worked on merging together to make this happen. Okay. The preferences of the programs of the residents are going to be limited, primarily because the data set has very limited characteristics of the residents. So there's going to be a vertical model, a homogeneous model where there's a human capital index H sub I, and every program agrees that this is the best resident, etc. Okay, and so that's going to be xi times alpha plus epsilon I. Epsilon I is going to be normally distributed. And I got this idea from talking to the chair of the residency program in Brigham Women's Hospital, because he's like, there's a pecking order, more or less, that the best residents tend to get offers at the tend to have the best programs ish where they can match. We look at the X's of those residents, we won't look at the specific resident. Okay, and so that's sort of the idea, and it gives you a unique stable match, easy way to simulate it. The highest human capital resident goes first, they pick whichever program they want, so on and so forth. Okay, so quite heterogeneous on one side, limited heterogeneity, no heterogeneity on the other side. Okay, to make some progress. And so salary endogeneity is going to be based on a control function approach. And there's going to be this idea of exclusion restrictions on each side that are going to tell me something about heterogeneity. So one thing that is allowed for is that residents might have preferences for the location of the program that they're going to train at. So maybe people who are who trained in a particular area will have preferences for programming in that area. Okay, and maybe where they were born, they have preferences for where they were born, programs in the area they were born. And if you are a rural born resident, you know, whether you match with the rural program or not. Okay, and so that's going to be identified, or the loose argument that I gave, which has been now formalized, is that basically there's an exclusion restriction that programs don't care about this. Okay, they don't care where the resident comes from. It's just that, you know, this is what the program cares about. That's what the resident cares about. So whenever I see, relative to the central tendency, more matches based on where you were training or where you were born, I'm going to attribute it to the residence preferences for the programs. Okay, all of that sorting is going to be loading on that. Okay. So we're going to do a minimum distance type of estimation procedure. So there's a match that I observe in the data. Let's call it mu. And there are going to be some moments I can construct from the data as well as from a simulated match. So there'll be xi, which are the resident characteristics. Sorry, I switched the notation a bit. I apologize. There'll be the resident characteristics and the program characteristics. You take the essentially the second moment of that joint distribution, xi times zi. I see that in the data. My model is going to predict something about that. Then there's this within program variance of resident characteristics. Remember, I showed you those Monte Carlo plots, right? And so this is capturing exactly that. So take a resident in a program, take resident I, whose characteristics xi, take the average characteristics of all residents in the program, square it, and then look at whether there's a dispersion in that or not. Okay, if there's dispersion in that, there must be something else that's not captured by X that the programs care about. Okay, and there's going to be a second moment in that based on the kinds of peers. Okay, cross moment. So simulate minimum distance. I need to figure out how to simulate the match. That's pretty easy. I take a parameter alpha, take parameters delta, something that governs the distribution of beta, and I go to Whitney's toolbox. I draw the unobservables, okay, and I simulate the pairwise stable match, having the top resident pick the program that they want, subtract the quantity, number of seats of that program, program by 1, move on to the second resident, and so on, and I simulate a match. Okay, yeah.
I guess you kind of give the anecdote about the variance, but I was wondering, like, the variance-based moments, but I was wondering if there were other moments you maybe considered, or like how you kind of really decided to pick those. Yeah,
so I made decisions based on relatively limited knowledge at that time, where I did not have the kinds of proofs that we now have. How would I have done this differently? I think I might have gone to a likelihood-based approach. I think that's not infeasible anymore. Like a Gibbs sampler type of likelihood-based or Bayesian approach, which has Gibbs sampling, etc. in it, and that's what Paulo uses. And the beauty of likelihood-based approach, as Whitney mentioned, is that it captures all of the information in the data, and any sort of function of that is going to be. Okay, so you simulate it. You can compute the pairwise stable match. You do that many times. Fix your simulation draws. Very important. Can't tell you how many nights I lost because of that. And then you get the moments as a function of the simulated moments as a function of theta. Okay. And then you minimize the distance. You say, okay, m hat minus the simulated m hat of theta, compute the sandwich form, and you minimize. Okay. Any questions about how to do this?
Could you tell what the peer-based moment is?
Yeah, it's saying, look at x1, look at the average of the x2s of another dimension of the x's of the peers, and then you match them. What is it really doing? So here I've got the variance and this is like the covariance between x1 and x2. Did I make the best decision? No. But it seemed like based on the Monte Carlo that I did, that's what was guiding most of my work back then. In addition to the double vertical model, this seemed like it was getting me pretty good answers. All right. Now, I hope one thing that's coming through is that the paper's not perfect, and don't let the perfect be the enemy of the good, right? So you should still go ahead and make progress and think about what you've contributed, not what's sort of deficient necessarily. You should be aware of what's deficient, but not necessarily always let that stop you, as long as the contribution is substantial. That is an opinion, not necessarily something that everybody agrees with. Okay. So that's how you estimated that's how the model was estimated. Let me tell you a little bit about the preference estimates of the residents for the programs. Here are various characteristics of the programs, and it tells you a salary equivalent term for that. Okay, and I want to sort of say, okay, if I compare a program that has a 1 standard deviation higher or lower case mix index, what is the average willingness to pay to train at those programs as opposed to other programs? That's sort of how you want to interpret those coefficients. Not if you took a program and you change its case mix index. That's not the intention here. It's about the average willingness to pay of those types of programs. So the case mix index has a willingness to pay of about $5,000. So residents are willing to take a salary cut in order to train at programs with a higher case mix index. Case mix index is a measure of the complexity of the cases that you see, and that makes sense. You are there to learn, and so you are potentially willing to take a salary cut in order to go to a program with a better, more complicated case mix index. My medical resident friends always want to go to the programs that have lots of patients with gunshot wounds in the inner cities, right? Like, because that's where you learn. That's where you learn the most. Okay, so that's what that is. NIH funding, like the big medical centers that are academic, that's where the medical residents want to go to. They wouldn't take a salary cut in order to go there. Larger hospitals, etc. Okay, and then there's some preferences for going to the same medical school state as where you trained and what state is where you trained. Okay. So these are going to be reasons why residents are willing to take a salary cut in order to go to a program that they want to go to. And so there's a large willingness to pay for going to a higher quality program. Okay, so now let's imagine for a second that we took the match and we removed it, and then we had a market where you could negotiate salaries. What would that negotiation look like when you had multiple offers? Anyone? Should I cold call? I do have your names in front of me. So somebody who hasn't spoken up so far, perhaps.
The question?
I should repeat the question. So imagine you're a medical resident, okay? And there's no match. You have multiple salary offers. And you're like, okay, let's try to negotiate. I'm the program director. Let's simulate that interaction. What would that look like? What would you come to me and say? Let's say you have a salary at program A that is, $40,000. My salary is $30,000, but I'm MGH. I'm Mass General Hospital. Somebody who hasn't spoken so far, or at least in my class. How would that go? Carl. Sorry.
So I guess I would start by telling you my salary if I have to tell the truth.
You have to show me the offer.
I have to show you the offer.
Yeah.
And then I'd show you the offer.
And what would I say?
You'd probably say I'm MGH and you just want to come here. And
Exactly. I would say I'm MGH. So yeah, you can take your $40,000. Okay, so that's what would happen. And what would that mean? That this negotiation wasn't very effective, right? And you're not going to get paid the marginal product of your labor, which is what there were some economists, famous economists, who wrote a brief in favor of the plaintiffs, of the resident plaintiffs. And they sort of said that, okay, without the match, you get the competitive wage, which is the marginal part of labor. And Kurt just explained why you wouldn't get the marginal part of labor. Okay, there's a large distribution of willingness to pay. To get to a better program, you're willing to take a salary cut. Okay, so maybe you're a hotshot resident, and that's why MGH wants you, and you're very valuable, but yet MGH doesn't need to pay you much in order to attract you. It only has to pay as much as what your next best offer is, right? Which may be at a good place too, Brigham Women's. But Brigham Women's Hospital also doesn't pay a lot because they also have a limited number of positions, right? So there's scarcity of residency positions. And because there's scarcity of residency positions, there's going to be a salary markup. It's regulated. Okay. So why did I go through this exercise? I went through this exercise because when you think about your counterfactual, you want to simulate it in your head too. You want to say, if this was the world and it looked different from what the world looks like, what would happen? How would the people interact with each other, right? What would the change in the rules mean about the interactions? How does it differ from the current interactions? And that will help you illustrate, at least to yourself, the economics behind the rule. The economics behind the rule that you cannot negotiate is to, okay, now let's allow a negotiation. Let's think about what the equilibrium will look like. What would that interaction look like? Imagine yourself as an agent in that new market with the new market design. Okay. And what does that mean? Okay, so here's some sort of formalization behind what happened, the history of it. So a group of residents in 2002 alleged a price fixing conspiracy in which they said that the NRMP matching program has the purpose and effect of depressing, standardizing, and stabilizing compensation below competitive levels. And the reason that's inflexible salaries and a restraint to competition, the inability of Kurt to negotiate with me, that is resulting in this. Okay, and so they used a perfect competition benchmark as an alternative, and Orly Ashenfelter's brief said that it's exactly Catherine's $80,000 based on salaries paid to nurse practitioners and physician assistants that would have been the counterfactual match. And so each resident faces a damage of about $30,000 because of this conspiracy. Okay, the lawsuit was dismissed because Congress enacted an exception to antitrust law for the medical match. Okay, so it went through the first round, and there was a law in Congress in the Pension Equity Act as a line, and said that there's no that for the purposes of antitrust law, the medical match is excluded. Participation in the medical match is excluded. So let's think about the counterfactual. It's a competitive equilibrium in which there's going to be an assignment of residents to programs, and resident programs with fixed salaries that clear the market. So that so now there's going to be essentially negotiation, and so there's going to be no case in which Kurt wants to go to any potential offer from any other program at the going wages that are program resident specific. Okay, so now the equilibrium concept allows for flexible salaries in addition to matching. And then it's it's a core allocation that corresponds to the Shapley-Schubeck assignment problem. So it's not just enough to simulate it in your head. You need to know some economic theory to try and like map it to a particular equilibrium concept. That's how theory also plays a role. And so it has these two properties. The allocation is individually rational, and no resident program pair would prefer recontracting with each other at potentially negotiated salaries. And so So that's sort of the equilibrium concept now. Okay, so why would there be a markdown in salaries here? Buell-Levin had a paper that showed that without flexible salaries, the match can depress salaries. And this paper is going to give you a different reason, which has got to do with the capacity constraints. Okay, so this is going to say it may not be the match, it could be the capacity constraint. So imagine every program can match to one resident. And there are n residents and programs. The quality of the program is QJ. The utility of the resident for the program is A times QJ plus the wage. So residents like the wage. And then the resident program pair produces some output F of QH, H comma Q, that is net of training costs. Okay, so let's get rid of the Beckerian reasons for salaries being below the value of the job because there's some training. Okay, so let's think of H as net of training costs. In the Beckerian model, the training costs are paid by the workers, right? So that F be the thing that would be not net of that, and let F be supermodular so that higher quality resident to the higher quality program produces more output for the program, and the residents and the program's profit is F of HQ times W. But each program can only hire one resident. Now, what happens is that because of this A of Q term, you're not going to get salaries equal to F. So we can, in fact, bound the salaries without knowing F. Let F be the output net of costs, and let A of Q be the implicit tuition, which is how much is the value of training. And you can show that in any competitive equilibrium, salaries are going to be marked down by this much. So the markdown at MGH is going to be the highest relative to the output. And markdown at the lower quality programs is going to be close to 0. Okay, so that also results in compression. Okay, and so it results precisely because residents are willing to pay for training at higher quality programs. Just like, you know, you don't want to go to necessarily the PhD program that pays you the highest stipend. You want to think about the future, right, for yourself. And so it's kind of like a compensating differential. It's not exactly a compensating differential because it's not that the utility at every program is different. It's a lower bound for the salary depression in a general class of models. In fact, the bound is achieved when F only depends on H. Okay, so you can take these estimates and then you can quantify that implicit tuition by solving for the lowest markdown that is sustained in any equilibrium. That's, you know, you can look at the paper if you're interested in that. That's not the point of the exercise here. It's just to show you that the estimated implicit tuition, depending on the range of estimates, is between 23,000 and 43,000. So between half to all of the gap between Harry and Catherine's estimates is explained by this thing called implicit tuition, right? And if you think about it, it makes intuitive sense that you know, during your training years, you're paying some implicit tuition if training is scarce, if high quality training is scarce. Okay.
It's not just that, it has to be general.
Has to be
General.
it cannot be firm specific. It can't be that my training is only useful for MGH, and by design these programs are such that, you know, you graduate from MGH and then you work somewhere else, right? You like finish your residency program and you work somewhere else. Yeah. Okay, any questions about that example?
Go back to the writing and patterns. You set up like pure characteristics without I shop. Is that how come?
Great question. So your name is? Tension. Yeah, great question. So put a fast one on you, right? So there's no epsilon IJT. What's with that, right? Okay. So normally we would have an epsilon IJT that's logit. Okay, you could do that in this model, in principle. Okay, that wouldn't be identified, or at least to my best understanding. Maybe now it would. Yeah, maybe now it would be. At the time, I thought that it wouldn't be identified separately from XC. the distribution of XC. Okay. But why do we put the epsilon in the consumer choice model in the first place? Okay. I actually don't think that the independence assumption in the standard consumer choice model is a very good assumption. Because what that means is there's implicitly a lot of unobserved characteristics of the products and a lot of unobserved preferences. There are lots of products. There's got to be a lot of unobserved characteristics of the product and lots of idiosyncratic reasons why people like those characteristics. If you want to think about this in characteristic space that people like, and that results in this independent shock that's consumer independent and product independent, right? So I think that sort of a micro foundation that's based on a characteristics model has some appeal to it. So this model captures that. In the consumer choice case, it will be very difficult to have this model explain the data because there'd be these cases of dominated choices. Like, if there'd be some cases where, that you wouldn't have, you wouldn't be able to explain the market shares. It could be that for whatever parameters you look in this model, there'll be some choices that are worse than for every consumer as opposed to some other choice. And so once you have this epsilon shock, that problem goes away. Okay. Now in the matching market case, the dominated choice can exist because there's only limited capacity at the best programs, at a better program, right? They can only take about 8 to 10 residents or 20 residents, whatever that is. And so that same problem doesn't show up. Okay. Now that doesn't mean that the simplification of this model is strictly better because there's one unobservable XC, right? You might want to have a factor structure with lots of unobservable characteristics and lots of unobserved factor loadings that are that are consumer specific on these loadings. That might be a better model. So there are two polar things. One is the epsilon IJT IID shock. One is this one. World is probably somewhere in the middle, is my guess. Anybody has other views on that? That's totally fine. Okay, so that's the sort of story about the paper. Some sort of background of the institutional process. I hope I gave you a little bit sense of the market design, empirical market design process. You sort of engage with the market, think about it. You try to figure out how to use the data. You use the equilibrium assumption, think about which rules matter, which rules don't matter, and use that to craft a research paper around it. I would be amiss if I did not talk a little bit about the TU models. So let me spend a little bit of time on those models. They have some appeal to them. So the transfer utility model, one of the classical models, is the Chu and CR model from 2006, where there are two sides again, I and J, index by I and J, one-to-one matching. And what you've got is the value of I from value of agent I, who's of type X, matching with an agent of type Y, the discrete types X and Y, is alpha of X, alpha sub XY minus some transfer that is XY specific. Okay, plus epsilon I times epsilon of I sub XY. So each individual I has some preferences for each type of the other side. Okay, they don't have preferences for specific agents on the other side. There's no epsilon IJ. It's epsilon IY, really. Okay, conditional on X. And similarly, there's U sub J of XY. So there's the gamma of XY plus the transfer. It goes from one person to the other, so there's no loss, right? And then there's the epsilon sub J XY. Okay. Now, conditional on the transfer vectors, you can come up with the demand function and the supply function. You were trying to, if you wanted to couch it in terms of demand and supply. So at the transfers tau of XY, what are the proportion of agents of type XY of side I that want to be matched to type Y? Type X that want to be matched to type Y. Okay. This minus the share that want to be matched to the outside option, that log share difference is given by, because it's logit, it gives you this alpha of xy minus the alpha of the outside option minus the transfer. The supply is people of type Y wanting to match with people of type X. Okay, and those shares are given by this. Let's say that there's equal share mass 1 on each side. Okay, and so in equilibrium, demand has to equal supply. That's going to determine tau. All right, and you get that this closed form. There's a closed form for the alpha of xy relative to the alpha of the outside option for type X, and gamma of xy relative to the outside option for type Y. Okay, so what I'm going to do is I'm going to just equate these two mu's, okay, and solve. And it's given by this expression. All right, I'm sure that if you spend 3 minutes tonight, if you're so inclined, you'll be able to arrive at this, okay, by setting equality. And you can see that some of the transfers is identified. Okay, again, not the individual components. It's only the sum that's identified. Another thing that's identified is alpha minus tau. You can see that directly from these two equations, and gamma minus tau. Okay, and so this is for the logit case, and then Galachon and Salanier extend this to other functional forms. And the trick they use, if you're interested in another link, is exactly the same trick that John mentioned yesterday in this paper of Rockefeller meets McFadden with convex duality. And so that allows them to generalize it to other functional forms. Okay, so there's like these kinds of things come up quite often, even in these models. And then there's an extension for the imperfectly transferable utility model by Galachon, Commoners, and Weber, where you can transfer some utility, but there's some portion that gets lost in the transfer. Maybe there's a leaky bucket, and that leaky bucket results in some loss during that transfer. Okay. And so if you have if you're interested in a world where that looks like more like this, then you could use this. Then there's another class of approaches that is based on work by Fox and some co-authors of his as well, that had an early semi-parametric approach that had some initial issues, but has been fleshed out a lot more now. Okay, so I will mention it. So imagine that there's an upstream downstream firm pair J and I that receive payoffs, pay pi of ij for the downstream firm minus some transfer between the firms, and pi of ij u plus tau ij. So there's some total surplus fij. Now, in the transferable utility case, you know that overall efficiencies, overall welfare is maximized by a stable match. Okay, and so if I took the observed matching mu, and I constructed a counterfactor, or swapped people by switching J and I would get the lower match. Okay, so for any other alternative mu prime, I would get a lower total surplus. Okay. For F. Okay, and so in particular, if you swap I and I prime's partners, then everything else cancels out. Okay, kind of like how Bob talked about finite dependence. Similarly, like everything else cancels out. Okay, and so the swap motivates an inequality that Fij if I and j are matched plus Fi prime j prime if I prime and j prime are matched has to be higher than flipping the matches of I and j. Okay. So that's true if F is the true underlying primitive payoffs. Okay, and Fox goes from there to motivate a maximum score estimator that's akin to Mansky 75 that says, let me take some characteristics xij that I observe multiplied by theta. So that's a parametric form for this, and let's make that happen. Let's look at those same inequalities and maximize the objective function, the maximum score objective function by saying, let me find the least number of deviations of that inequality. Okay, so that initially we didn't know necessarily what is the distribution of primitives, and that would justify a maximum score estimator. And there is a paper by Fox et al. In 2018 that shows a general class of unobservables under which in the additively separable unobservables case, where you can take the inequalities and make that work and minimize it, and you get an estimate of theta. The estimate of theta tells you gives you an estimate of the total surplus coming from the observed component of the matches. So it can tell you that this is how much matches between two different xij's matter from the observed site. Okay, so that was very brief on the transferable utility models. But if you're interested, here are some references. The survey article that I mentioned earlier that Paulo co-authored with me, I think that that one's in the Dropbox, and it has a number of other references if you're interested in this literature area. Okay, so I'll pause for any questions if you have any about sort of either the papers, the general sort of market design approach that I sort of mentioned, or anything else. Yes.
Have you seen this paper by Hitch, Portascu, and Ranielli on matching and dating in online markets? And so, they look at the matches and estimate a model with preferences from kind of decentralized matching and bargaining. And they suggest that, when there's slow search frictions, that dynamic process leads to something that's equivalent to a stable allocation from the deferred acceptance algorithm.
Yeah, so let me recap that paper for the audience. So they had, I don't remember all the details, but roughly they had data for some matching dating platform where you could swipe right. That back then it wasn't that, it was something slightly different. You could contact somebody, and based on who you swiped on or you did not, they estimated the preferences by saying that people who you contacted, you must have preferred to people who you didn't contact. And then they took those preferences, simulated the algorithm, so simulated the deferred acceptance algorithm on both sides to say, okay, what would be the matches? And in some cases, the other person also swiped right? And so you saw, let's call those sort of the matches, right? Then let's look at the types of people on characteristics that would be matched by deferred acceptance, and then what the data looks like. That's what they did. And they saw that it was kind of similar, right? So that's sort of saying that even though that market does not use one interpretation of this, a favorable interpretation for this work, is that even though that market does not use a stable matching algorithm in which people submit preferences and all that stuff, the sorting patterns of who gets to date whom look similar to what's produced by the deferred acceptance algorithm. That's sort of that's what you're saying. And yeah, this is the sort of type of juice that this literature is extracting. Like what types of people are matched with what type of
is it like somehow analogous to the revenue equivalence theorem? You have different mechanisms, but they're resulting, in similar allocations, right?
So I wouldn't go that far, because Paulo showed you something which not like that, right? Because you have the Cambridge mechanism and the deferred acceptance mechanism that don't look similar. There are some theory papers that show that there are certain classes of mechanisms that require some properties like Pareto efficiency, etc. And in a large market, they produce asymptotically equivalent matches. So Marek Picia has a number of papers in that vein. Even the revenue equivalence theorem has some conditions, like it has to be efficient matching, right? And is one of the requirements in the revenue equivalence theorem. So there's some requirements like that. But yeah.
Yeah, there's one other paper I want to ask you about. There's a paper by Chao Fu called Equilibrium Applications, Admissions, and Acceptances, right? So she models the whole process, in the JP in 2014. So it's modeling the college market, US, which is a dynamic mechanism. But then the question is could you take her preferences and then try to say, suppose we ran it through a deferred acceptance algorithm, what would there be a more efficient outcome, right?
Yeah, you could do that counterfactual. I don't think the paper did it, but if I remember.
Has anyone ever done that or tried to look at?
So the paper that Paula mentioned of mine is there aren't that many papers that look at compare decentralized and centralized markets. And part of the reason is that getting a handle on a decentralized market can sometimes be quite hard, because especially if you want to model the frictions well, and Chao's paper is one of the exceptions where they've been able to do that, because you have to like get a sense of exactly what the process is. You have to model those frictions, and then you have to say, okay, I get this data from a decentralized system, model all of those frictions, estimate preferences, and then compare to a counterfactual. So when you don't observe enough about the market, it can be hard to model the frictions appropriately, because you have this identification issue. You can see these models are already somewhat under-identified. And so now try to model the frictions on top of that, it becomes kind of hard. And so, so that's sort of the barrier. But yeah, typically if you have good insight into how that works, and actually you'll see in the conference a paper where they look at interview frictions, and they try to model what the interview frictions imply about the efficiency of the matching.
Great, thank you.
Great, thanks everyone. So let's all head out to the steps of the economics department. You should follow us and we'll take a picture. And tomorrow, 9 o'clock.